So let's talk specifically about what a modern data warehouse architecture in Azure would look like. So everything you see in blue is available as a PaaS service offering in the Azure ecosystem. These are services that you don't have to implement VMs, you don't have to develop your own high availability and disaster recovery for, you don't have to design encryption because it's built into the service capability. There's no application to patch, no operating system to patch. You can easily scale. So the PaaS approach to delivering services in the cloud is the future versus IaaS VMs in the cloud. And Microsoft offers a complete ecosystem for data platform that enables, through PaaS services, your varying workload types. So our recommendation is Adastra. Like a lot of organizations try to push EDW solutions through big data platforms, or big data platforms through EDW solutions. Our recommendation is use the suite of PaaS services that are available in the Azure ecosystem and choose the right service for the right workload. And so through a big data EDW type solution in the blue path, with your EDW through a platform like Azure SQL Data Warehouse, through ELT load patterns, through Data Lake and Polybase into your data warehouse schema, into Azure Analysis Service for semantic models, reporting out of Power BI. And if your organization is slowly maturing in the cloud to that level, but you want to benefit, say, from Power BI today, you can, because you can implement Power BI and work with on-premise data. And then as you build out the ecosystem and introduce in the data lake, in the data warehouse, in the semantic model, a more robust enterprise scale solution in the cloud, you can point your Power BI sourcing into those platforms as you mature. But obviously, while a SQL data warehouse is great at a structured data platform where you do things like track, establish relationships between tables, you have facts, you have dimensions, you have historical versioning, and within this SQL language, you have 2,000 SQL statements and functions that allow you to effectively build and implement that kind of workload, which, by the way, a Hive cluster will not be great at, because a Hive cluster will give you 200 SQL statements and functions to implement that workload, where you want a mature set of 2,000 SQL statements and functions to execute an EDW workload. That's one of the reasons why a lot of attempts to implement EDW through Hive solutions don't work, because you don't have the tools you need for all those different types of complex data warehouse workloads. But what it's not good at is your true big data, 3V, unstructured data, data science type workloads. And so in that case, there's a different suite of PaaS services that still work with Azure Data Factory for orchestration, that still work with Azure Active Directory for identity management, that still work with Azure Storage for landing of data, whether it be structured, semi-structured, unstructured in the cloud at cheap $10 per terabyte potentially per month cost levels, where you can then integrate into your big data workload through one of the big data platforms in the Azure ecosystem, also implemented through PaaS services, whether it be HD Insight or Data Lake Analytics or Databricks. And so I just want to spend a few more minutes today talking about how to position and use those services correctly in your organization. Now, by the way, we support batch-based orchestration patterns through Azure Data Factory into this ecosystem. We also support real-time ingestion into this ecosystem through PaaS services in Azure. So if you imagine a JSON message or an XML message that you have to pick up maybe as from an IoT sensor, and you have millions of these an hour that you have to collect and ingest and feed into either your EDW or your big data platforms, you could use something like Event Hub and Stream Analytics, which is meant for that IoT millions of messages scenarios. Or there are other patterns more aligned to heavy transformation, where you use something like Logic Apps and Service Bus with guaranteed message delivery to handle that kind of near real-time data ingestion through message-based JSON or XML message payloads that get transformed and managed delivery of as you ingest. So there's multiple ways to deliver real-time patterns through the Azure ecosystem. That just highlights one of the patterns, Event Hub and Stream Analytics. So as I said, a complete suite of PaaS services. Choose the right service for your workload. Don't stuff EDW workloads into big data PaaS services. Don't stuff big data workloads into EDW services. And you leverage this ecosystem appropriately. If we think of the different model types that you as an organization might need to support, there's relational model types, which you're used to for your OLTP type systems. And so we have PaaS services in the Azure ecosystem to handle your relational models, whether it be SQL database, by far the most common PaaS type in Azure, or MySQL or Postgres PaaS services. I talked about the SQL Data Warehouse PaaS offering, which is different than a SQL database. SQL database is a single node, and you can scale it up to 60 cores and hundreds of gig of memory. But the SQL Data Warehouse, it's more like its competitor would be like Snowflake, where you have an MPP platform with many nodes working together. If you have a big fact table, you spread the load of querying that big fact table across all the nodes that are part of the massive parallel processing cluster. And so you can use Azure SQL Data Warehouse when you are dealing with data warehouse reporting on billions of rows of facts or transactions versus your OLTP workload, which you would leverage an Azure SQL database for. But there are lots of data workloads that don't line up to structured tables with foreign keys and primary keys. So an example might be collecting IoT sensor data, where the data that you're collecting is sparse. Maybe you have a JSON with 50 data elements, but one message payload may have 3 elements populated. Another message payload may have a different 5 elements populated. Trying to stuff that kind of payload into a normal SQL table, it's not what SQL tables are designed for. And so we have these NoSQL platforms through Cosmos DB model types that are really designed for that. So key value, you have a key, you have a hash string, your application reads the hash string to break out the data, but the hash string can be short or long, depending on whether 3 elements or 5 elements came in from the JSON message. Or a document where you actually just attach the JSON to a key. So you got a JSON, attach it to one key. Got an XML, attach it to a key. And you can interact through your applications with that kind. Or a graph model, which really is focused on relationships. An employee has a department, an employee has a manager has multiple employees. So a graph database really focuses on entities and relationships. So Cosmos DB is the platform in Azure designed for those types of workloads. And then we have some big table type platforms that come out of the Hadoop ecosystem through HBase that implement a column family model where you have a key and a set of fields attached in one HBase table and another same key but a different set of fields attached in a second HBase table. And then Azure search models are meant for indexing large volumes of web content. Time series are meant to handle billions or trillions of IoT sensor information as it flows into Azure, with the ability to report quickly and efficiently on this series of events that have come through your IoT sensor realm. And you've probably heard of Common Data Model, which really uses the blob storage technology, Data Lake Store Gen 2, to be able to store data in files and then read it through a common data service and use Azure Storage as your storage schema for your platform. So again, don't try to fit NoSQL IoT sparse sensor data into SQL platforms, right? Choose the right platform for the type of data and the type of workload that you're implementing in Azure. So if we think a little bit about the big data capabilities in Azure, so we have EDW solutions, which we just talked about, where you can, through Azure SQL Data Warehouse, have durable, persistent, historical, well-integrated, well-cleansed, well-matched, well-validated data. But, it takes time and effort to integrate your data successfully and ingest it into your EDW platform. So a lot of organizations implement a hot-cold model where maybe 20% of your data sitting in your data lake flows through into an EDW for your regular reporting, your regular analytics, covering 90% of what your organization needs day to day from an analysis and analytics perspective. But then the other 80% of the data, which may not be as well structured, which may only be needed for certain data science workloads or certain analytics workloads infrequently, it doesn't make sense to invest that effort to integrate it into your structured EDW schema. And so it might just sit in the data lake, and then you're going to use a big data platform to work with that ad hoc as the demand comes in. And so in the Azure ecosystem, Microsoft implements Hadoop platform capability for that type of use case, that high volume, high variety, high velocity, no need for structured data warehouse storage of your data. And so the platform that Microsoft offers as a PaaS service to deliver that is Azure HD Insights. So through Azure HD Insights, they've designed specific cluster types. Each cluster type aligns to one Hadoop technology capability that you can spin up at low commodity nodes. So these are Linux nodes that don't have a high cost. Because you're running open source software, there's not a high compute cost to running these clusters. But you're going to be able to take files from your data lake, go through a MapReduce or TES process to do some analysis through Hive or Pig scripts, create a data file result, and then that can be written back into your Azure storage, or you can mount it in a Hive query cluster as sort of almost like a SQL database, but through Hive query, live long and process cluster that provides some SQL Server-like caching and optimization. It's not going to perform like SQL Server does, but you're going to get better performance and query from straight files through a Hive query LLAP cluster. And then you can see some of the other cluster types, whether it be in-memory, high-performance Spark clusters. What differentiates a Spark cluster from a traditional Hadoop MapReduce or TES process? Traditional Hadoop MapReduce TES, you have files, you have source files, you bring them in, you run your Hive or Pig scripts, you come up with new results, you write them back as files, you then have a step 2 where you start with files again. So it's always files, process, where something like Spark, if you ingest it into memory, and every step stays in memory, and so you obviously get a huge performance boost running your big data process all in memory rather than through multiple steps involving file storage. And so Spark is a specialized platform designed for that, but has a lot of challenges to light up and use effectively, as I'll describe in a minute. Here's the limitation of Azure HD Insights, however. It's not great at security. So if you want to mount a data model and have Azure Active Directory group-based security, where you can control either vertically or horizontally who can access which data, you're not going to get there with HD Insight. If you want a collaborative development environment where a team of developers can all work on the same process through the same cluster at the same time, you're not going to get there with HD Insights. If you want like an environment where you have easy implementation, easy setup, and you can achieve these big data goals without a lot of open source platform knowledge, open source programming knowledge. Again, HD Insight may not be the right platform. But if you're looking at the lowest cost, heavy workload, ad hoc workload type PaaS service in Azure, where you don't have a durable big data or heavy monitoring, heavy auditing, heavy orchestration requirement, then HD Insights can fit the bill. However, if you think of a modern Hadoop technology landscape, there are many components that need to be supported. Whether, as I started to mention, the batch, the real-time, the search, the visualization, the analytics, the lifecycle management, the metadata and governance, the monitoring, the automation, the security, the orchestration. This is where I'm just trying to make clear that a complex big data environment needs to support all these use cases. And in the open source Hadoop world, there are many different platforms needed to support all these different use cases for durable big data. And so, as I said, HD Insight, it doesn't have all that functionality covered, right? So how should you use HD Insight? Well, first of all, you could use it as an ad hoc big data workload processing platform, and then the result of it can be integrated, if it's structured, into an EDW platform. So you do the data engineering workload in HD Insight, but then the output resides and sits in Azure SQL Data Warehouse for your durable, security, orchestrated, controlled, monitored access, audited access to the data. That's one approach. Another approach, which is actually very cumbersome, is you can actually just spin up Azure VMs and then just run your free open source software Hadoop platforms on those VMs to achieve that ecosystem of Hadoop capability. A third option is you can leverage Databricks. So I'm going to spend a few minutes talking about Databricks specifically within the Azure ecosystem, because it was basically designed to fill that gap. So that gap I just talked about with HD Insight, Databricks addresses that gap natively with its PaaS service offering within the Azure ecosystem. On the top performing Hadoop platform, Spark, so you know you're going to end up with the best performance possible by using Databricks as a platform. It supports collaborative notebooks where developers can work together with Python, R, or Scala programming to ingest data frames and engineer data and leverage Spark ML or SQL libraries for advanced analytics or data interactions. It's able to address a lot of those gaps in my first bullet point there regarding it has a data model that you can apply security to. It has the collaborative notebook for collaborative development. It's easily implemented and accessible for multiple developers and multiple end users and report developers. It has built-in scheduling and orchestration capability. It has built-in elasticity. That's another huge advantage. Databricks has a serverless model where you can go in and say, I want my minimum cluster size to be 2 nodes, I want my maximum cluster size to be 10 nodes, and I want Databricks to auto-scale to the 10 nodes the 1 hour a day where the compute is needed, and then for the other 23 hours of the day, run on 2 nodes, and then just service the results through the in-memory model built into Databricks from the 2-node cluster. So I've done that as an example at Just Energy. We implemented Databricks to process a heavy data engineering workload that was taking 2 days a month to execute on an on-premise SQL server related to cost amortization across 15 million contracts. And what we did is we took that workload and we moved it out to Databricks in the cloud and are able to do daily amortization in 1 hour, which for a process that was taking 2 days, and we set up that 2 to 20 node cluster where it'll scale to the 20 nodes the 1 hour a day. We need to do the heavy amortization and then run at the lower cost 2 nodes to report the results of the amortization in Power BI. It has great integration with AI capabilities, so we used Spark ML to work with an analytic model at that same customer to do what we call contract retention modeling, where we determine based on historical factors and historical training whether a contract is likely to be canceled in 3 months or 6 months or 1 year or live out the duration of the 5-year contract. So that was also something we used Databricks to do. And through, as I said, through that serverless pool, we weren't paying for the expensive 20-node cluster, except for the 1 hour a day that we needed it. And it can also auto-stop. A lot of other services in Azure will not turn themselves off when a window of idle opportunity comes. You can set it up. We didn't in that use case, but you can set up the cluster to say, if nothing has happened in an hour, shut down. And so that's a neat capability as well. So if you compare processing data in Azure Databricks to HD Insight, you're going to pay, in general, double. All this capability comes at the cost. So you're going to pay double on initial look. However, when you look at the auto scaling capability, when you look at the auto off capability, a lot of scenarios actually end up cheaper under Databricks than they would under HD Insight because of this advanced capability. So, if I compare Databricks to SQL Data Warehouse, obviously meant for a different type of workload. SQL Data Warehouse is great at structured data workloads, but if you need advanced analytic programming like R, Python, Scala, or Spark ML support, if you need integration with real-time patterns, the auto-scaling serverless pools, built-in orchestration capability, better control over the compute type and pattern, native support for in-memory analysis. With Azure SQL Data Warehouse, you have to add Azure Data Factory for orchestration. You have to add Azure Analysis Services for in-memory analysis. And greater control over your compute. There's probably some workloads that are big data that actually make more sense to run in Databricks than they would necessarily in SQL Data Warehouse. Although, like I said earlier, if your goal is to facilitate a structured SQL data warehouse, you need the 2,000 SQL statements and functions supported in Data Warehouse to do that. But you can do a lot of cool big data workloads, as I said here. And if I compare Databricks to HD Insight Spark, you have one of the challenges with Spark is you turn it on and you spend a month tuning it. With Databricks, you turn it on and you spend a minute tuning it because you chose the tuning characteristics during the cluster setup, and it auto-tunes itself. And so as a result, and with a lot of the optimizations built into Databricks, on average, you can expect 10 times faster performance off of a Databricks cluster when compared to Spark, and 40 times faster performance off of a Databricks cluster when compared to traditional HD Insight Hadoop cluster or FOSS Hadoop cluster. So, if you need to implement predictive analytic models and apply data to it, you have heavy data engineering workloads and you want to leverage the serverless scale. If you have real-time data integration, these are all arguments for Databricks. You get those performance boosts when compared to traditional Hadoop and traditional Spark. And you get all that collaboration and job management and security and Active Directory integration and auditing and built-in encryption, things that are difficult to do through HD Insight or FOSS on IaaS. Durable data sets, in-memory data sets that you can report from through Power BI and other platforms, dynamically scaled to workload, process data through advanced analytic languages. So we as Adastra, we're a global organization with over 2,100 professionals, 210 million revenue per year. We're spread across through 40 countries and offices throughout the world. We have 400 professionals here in Canada. Within my Azure practice globally, I have 200 professionals in terms of Azure data engineers, Azure architects, Power BI developers. And so we've had a lot of success delivering Azure cloud solutions for our customers. The growth in the last 2 years has been exponential to mirror the growth of Azure itself. We as an organization help customers enable a digital enterprise, a digital business through our various practices. Our Azure cloud practice represents about 90% of what we do in Azure. We have expertise in other cloud areas as well. But certainly through big data, through governance, through AI solutions, through our data science team, we help our customers achieve their digital enterprise goals.